All right, welcome, gentlemen. Please read the description about credit. All right. Right, so the comment section comes once I complete the video. The comment section is going to post. So the live chat, I just want to keep the live chat just for people that are here live, that are engaging in the conversation. But the comment section will post once I stop the live chat. So keep that in mind. Okay. Again, read the description about credit, gentlemen. Okay. All right. So, we have a few people in attendance, which is fantastic. All right. So, if you're here, welcome. So what this is just a makeup lecture for Finite Mathematics. I think we did pre-cal yesterday. I think that video should still be there, so you can check that out anytime. We're going to do one for Finite Math today. And then hopefully before the end of the day, we can get maybe some college algebra in. I don't know. I got about 2 hours remaining, so we'll see how I feel. But for right now, this one is specifically for my finite math students. So, all right. But anybody's welcome to watch the video, listen, engage. If you can answer any of my Easter eggs, I've been recording credit that's been given out to people. So, extra credit opportunities do arise during the presentation. Just kind of keep that in mind. Oh, it's not video frozen. Maybe I can get it going again. It's still going there. Sure. Okay, so from there. Oh, okay, yeah, we're back. All right, Mr. Lewis, welcome. Please read the description. Okay, so because I'm not going to check the live chat later, but I can't see people in attendance. And if you want to get attendance credit, if you want to get credit for the extra credit for attendance, check the description. Yes, Miss Barrett, thank you. welcome. Check the description on how to receive credit. So right now, this is just a live session for people in attendance. But to get the credit, once I post a video, the comment section will post, and then just leave your information there, and that's how I'm gonna check that later to give people credit. All right. All right. So let's, without further ado, let's just go ahead and get into. This is just a lecture for finite math. Okay, so this is just a makeup lecture, just to kind of keep us honest. All right. All right. All right. Okay, so in finite math and also in my quantitative reasoning, we're actually kind of doing similar topics. Is it not? Oh, I gotta bring it back. Let's go back here. Hey. All right, that's better. Okay, we should be good to go. So let's see what we got here. Okay, so in my finite math class, we have begun chapter 12. I really like this chapter. I mean, it's all very interesting. It's all in how we choose to look at it. It all has wonderful applications and interesting topics and ideas, and this is just different. And you know, I like this topic because it's kind of like the bridge or the gateway between a lot of different fields. Like for me, when I was studying math coming up, this topic came up in a class called set theory, and set theory was like the bridge between traditional math, numbers and solving problems and analytical skills and things like that. But then in the bridge into the advanced math, where we're proving things, we're moving away from less from numbers and using more concepts and proofs and theorems and corollaries and all those kind of things. And so logic, and then it's like this. And so the students actually hit me to an artist called Logic, and I was like, oh, I like Logic. It's an artist. I was like, but that's not the kind of logic we're talking about right now. It's a different kind of logic. I think I like it. The conscientious rapper, people that are about consciousness and things of that nature. Oh, my signal, okay, but like it's okay. All right. But what we're doing here with logic, so like I know one direct application of some of the things that we talk about in this section, like they pop up in law, like with proofs and proving the validity or the truth value of different statements and things of that nature. So that's what we're doing in this section with 12.2. All right, so let's take a look at some of the. So we did 12.1 last time, so we're going to look at 12.2 truth tables up, and we are here. All right. So I need to pull up my filled-in notes. All right, looks like we're good to go. And I would like to introduce some lines. Now, this might look like a lot, but it will clear up. Even for paper, some lines. Now, I typically do not like to do presentations in line, but it helps me, my handwriting to be much better. Without the lines, it's even worse. So, just have to do the best you can with the lines. Okay. So, we want to start off with the definition. I can get that to come back up. Go lower. It's funny. It's the same time yesterday, so 3 o'clock. I'm gonna ignore it today, but 3 o'clock and 9 o'clock. There's this live game show that comes on every day. It's called HQ, and if it's a free game, it's a free live trivia game show. If you win, you actually win cash. I came close the other day. I was by myself. I wasn't even really paying attention. I just had it open and played. Out of the 12 questions, I made it to question 11. I missed question 11 and question 12. I was like, ah! And then yesterday, all the people that won, they won like $3,000. Crazy. I was like, yo. So anyway, that's neither here nor there. All right. So let's introduce this definition. So first we have a statement form is an expression formed from simple statements and connectors according to the following rules. Okay. So we have a statement form. A statement form is an expression formed from simple statements and connectives according to the following rules. And connectives according to the following rules. Okay. So the first thing that we have, just going to scroll up a little bit. Now the top is that surface flush. Yeah, surface flush would be okay. That's fine. So number one. A simple statement is a statement form. So a simple statement is a statement form. Okay. But number two, if P is a statement form, then not P is also a statement form. So if P is a statement form, comma, then not P is also a statement form. Is also a statement form. But then three, if P and Q are statement forms, then so are the following. So if P and Q are statement forms, so are statement forms, then so are, we have P and Q, so P and Q. We have P or Q, and P implies Q. P implies Q. Okay. All right. Okay, so let's get rid of some of these lines to kind of clean it up. Okay. So a quick recap. So we're defining what we mean by a statement form. A statement form is an expression formed from simple statements and connectives according to the following rules. So the rules are a simple statement is a statement form. So the same rules we have for simple statements, i.e. simple statements are things that where we can define it as either true or false. We saw some examples of some sentences that were not simple statements because we couldn't say whether they were true or false. They were either questions or exclamation or things of that nature. But a simple statement is a statement form. Then next, if P is a statement form, then not P is also a statement form. So, okay? And then also, if P and Q are statement forms, then so are the following blues. We have P and Q, P or Q, and P implies Q. Okay? So now this is how we identify a statement form. Now let's see how we use statement forms. So we have the following example. We want to show that each statement is a statement form according to the definition. We want to assume that P, Q, and R are simple statements. Okay. guess I could do some paper. Let me do some more paper. And you just have to bear with the lines. I will clear them up, but it helps me to write a little bit better. Me and my perfect imperfections. I love me and my perfect imperfections. Okay, so then A, as you should love yours. You and yours. Okay, so first we want to show that we're looking at P and not Q implies R. So that's the original, right? We have P and not Q implies R. So, you know, order of operations, we typically would start inside the parentheses, and then within the parentheses, we have a couple of cases. We can either start with P or the and or the not Q. So we would actually start with the not Q. Okay? So then if Q is a, so we could say something like, you know, since Q is a simple statement, then that means that not Q is a statement form. So the first thing we have is that first thing we have, let's do it over here. So we have not Q is a statement form. And that's just a direct application of the rule. Okay, so then if not Q is a statement form, and since P is a simple statement, that means P is a statement form. So this means that now the rules say that now it should be the case that P and not Q is a statement form. Okay. So now that means this set of parentheses so that means everything in the parentheses is a statement form. So therefore, we're going to have that P and not Q implies R is a statement form. Is a statement form. Okay. Oh, okay. So she substituted. She just quantified all this Q. I see. But that's fine. This is fine. Okay. So therefore, the whole expression should be a statement form. It's kind of like this whole domino cascading effect kind of thing going on. Okay. Let's look at B. So B, the originals, we have not P implies Q or not R. Okay. So again, where would we start? With something like this, we would start with the parentheses. Now we have nested parentheses, or we have parentheses within parentheses. So we would start with the innermost parentheses. Okay. So the innermost, we have Q or not R. So then we would start with the not R. Right. So we can say that not R is a statement form. Right? So now that not R is a statement form, this means that Q or not R is a statement. Is a statement form. Okay? So now that means the entire parenthesis set is a statement form. Thank you for the notification. So now that we have Q or not R as a statement form, so this means that P implies Q or not R is a statement form. Okay? So then if all of that is a statement form, then the negation of that is going to be a statement form. So therefore, not all of that, P implies Q or not R is a statement. Okay? That's it. That's it. That's all that's really going on for that. Don't read too much into that. If there are any questions with that, don't stress about that. That's nothing major for this topic. That tends to flow naturally. Okay. Can I clear that somehow? Yes, I can. I'm going to get rid of this. Remove. Yeah, that's better. Okay. All right, let's keep it rolling. What's the time? So we've been going for about 20 minutes, more or less. Let's keep it going. All right, so next we have propositional calculus. So let's bring this about right there. Is this still good? Yeah. Cool. Okay, and let's introduce some more lines. Back paper. New lines. All right. So what do we mean by propositional calculus? Let's bring this back here. Cool. Okay. So propositional calculus is the manipulation, verification, and simplification of logical statement forms. Okay. So it is the manipulation, verification, and simplification of logical statement forms. I feel like, who was that? It's not Jesse Jackson. Al Sharpton? Who was that? It's the manipulation, the verification, and simplification of logical statement forms. It's just a lot of Asians going on there. Yeah. So anyway, but yeah, so propositional calculus is the manipulation, verification, and simplification of logical statement forms. So this allows us to see if two different statement forms form a logical statement that are equivalent. Means that they have the same truth value. Okay, so let's note that. So this allows us to see if two different statements form a logical statement. Form a logical statement or form logical statements. So let's make that plural. Form logical statements that are equivalent. This means they have the same truth value. So this means they have the same truth value. Okay. So then we can compare one of the simplest ways that we have for tracking the propositional calculus is through truth tables. Okay. So then we have truth tables are the main mechanism for determining the truth values of a statement form. So the truth tables are the main mechanism we have for determining the truth value of a statement form. Okay? So now, if you are in attendance, if you are live right now, if anything is not clear, be sure to get my attention in the live chat. I can see the live chat. So you can just stop, say, ask your question, and I do give credit for people engaging. You have to be engaging. The attendance is one thing. Uh-oh, is my signals okay? Okay. Attendance is one thing, but, engaging is another level. And you can actually rack up a lot of points engaging in these things. So just engage, just stay involved, and, you never know what will happen. Okay, so hopefully we can do an example. Let's see what's next. So this next piece. So let's see, if we consider the simple statement P, right? So if it's a simple statement, it means it can either be true or it can be false. So that means P has one of two truth values. It can either be true or false. Okay? So if we just did a truth table with just P by itself, again, P can either be true or it can be false. So that's the truth table for P by itself, a simple statement by itself. So now if we had not P, for instance, so again, the truth value for P by itself is true or false. So then if we do the truth value for not P, it's just going to be the opposite. So if P is true, that means not P is false. If P is false, that means not P is true. So that's the truth table for not P. Again, this is just an introduction, so it always starts off super light, super easy, and then we'll see where it goes from there. Okay, let's look at the next part. Oh, I see. Okay. So now, let's consider if we have the simple statements P and Q, right? P and Q. Then they each have 1 or 2 truth values. Now, we have the conjunction of P and Q. So we have, okay. So notice here we have 2 simple statements, right? P and Q. If we want to do all the combinations that we can do with true and false between these two, the number of rows is going to be 2 to the n. Okay. So since we have 2 simple statements, the total number of rows is going to be 2 to the power of 2, which is 4. So then we're going to have 4 rows total. So then to construct the truth table, when we do the first column, the first half needs to be true, second half is false. So that means 2 trues, 2 false. Then we cut that in half and we go by 1. It's not super clear when we have just 2 simple statements. When we get to 3 or more, that technique will make more sense, or you'll see it better. Now the conjunction of P and Q, right? So let's see. So the conjunction P and Q is true if, okay, let's look at this. So it says the conjunction P and Q is true if both P and Q are true. If both P and, let me stress that, and Q are true. Okay, so the word and, or conjunction, means this has to be true and the other one has to be true in order to be true. All right? So when we see the and symbol or the conjunction symbol is and so it's true if the first thing is true and the second thing is true. So both have to be true. So it's only true when they're both true, otherwise it's false. Okay, I'll make this the first Easter egg. I only have about 4 people live right now, so, and I might be counting myself, which is fine. I will open up the floor to somebody if they can just correctly give me what's the truth table for this conjunction P and Q. So what's going to be the four boxes? Now my clock says 3:09. I want to go for about 3 minutes. So what is that? 12. When my clock says 3:12, those points are going to be off the board. Okay. Somebody can correctly give me. First person to correctly give me this truth table filled in properly, like what are the next 4 truth values, I can mark you for extra credit. All right, so it should be about 2 or 3 people. I'm going to skip this one and come back to it. I'll watch the clock, and I'll try to watch the live chat. If somebody can provide the correct answer, then we can kind of give out some points, hopefully. Okay, so again, we still got about a solid 2 minutes. Somebody can correctly fill in that truth table. Okay, I'm going to move forward, and I will come back to that. Okay, so now we started taking a look at and, so let's look at the disjunction. Okay, so if we consider the simple statements P and Q, or let's just look at, okay, we consider the simple statements P and Q, then they each have 1 of the following truth values, either true or false. So again, we have 2 simple statements. So the total number of rows is going to be 2 squared. Total number of rows is 4. So then, the first half is true, second half is false, and then we go by ones. Okay, so the disjunction of P and Q. So the disjunction P or Q is true if P is true or Q is true, or if both are true. Both P and Q are true. So what the or the disjunction means is that, Mr. Cunningham, and he got it in time. Man, he is on it. Like, I think he got the ones from yesterday too. I see your Super Saiyan God Goku icon. That's pretty cool. Help for review. Somebody. Oh, this one. Okay, so yeah, I guess we could show it. Yes. This is good. Let's see. So this is what is it gonna pop up? Show. I want to show. There we go. All right, so Mr. Cunningham suggests, let's go back to the other one. He got it in time. Let's see if it's correct, though. So here's the previous. We have and. So now, we said that and is true if they're both true. So if we look at the first row, let's kind of do this so we can kind of be clear about what we're referring to. Okay, somebody else, if you're listening, really quickly, what's your favorite color? I will give you 1 minute. So on your end, after the delay, you might have 30 seconds. But when my clock says 13 after, these are off. What is your favorite color? Okay. What is your favorite color? This is for somebody else that hasn't gotten it. So you might have 30 seconds, maybe. Okay. This is just to see who's in attendance. Just an attendance check, like a roll call. All right, you got 30 seconds from now. But I'm just choosing a couple of random colors. What's the time? Oh, weak signal. Come on, get back strong. You guys got about 10 seconds. Anybody? Favorite color? 5, 4, 3. I think that's time. All right. Well, just seeing if I can get somebody to answer, but that's fine. All right. So now, when we do and means the first thing has to be true and the second thing has to be true. That's the only time it's true. So if we look at this first row, are they both true? We would say yes. So that's true. All right. If we look at this, are they both true? No, that's false. So we would write false. If we look at the third row, are they both true? No, it's false. The last row, are they both true? No, it's false. So that's how he got the result of true, false, false, false. That's correct. Okay. So then we have Mr. A. Extra credit 5 for this. All right, let's log it at least. We just have to go through this momentarily. So we got this. All right. Oh no, I didn't need to do that. I deleted it. Let me do it again. All right, cool. So now we have a copy of that. Okay. Mr. Cunningham. Yeah, it's a good try. Oh, you went on to the next one too? I see. I can't give you credit for the color. I was trying to get that to somebody else, but that's fine. We can show this one. So his claim is that the next one for or should have this result. So let's see. So if that was and, he got the and correct. Let's look at the or. This one. So now or means, Mr. Cunningham, which class are you in? If you just put that. I'm just curious. So his claim is that or should be true, false, false, true. Let's see. So or means either this is true or that is true, or they're both true. Okay. So, or if we look at it, so if we look at the first row, is at least one true? Yeah. Between these two, is at least one true? Yeah. So that would be true. Is at least one true? Yes. So then we put true. Is at least one true? Yes. So we put true. Is at least one true? No. So we put false. All right? So, Luckily, he got his extra credit on the first one. But the thing about luck is that chance favors the prepared mind. So he was prepared. He knew to listen to just a few minutes. He knew that sooner or later I would ask some kind of simple question or light question that people can take advantage of. So can't be mad at that. But yeah, so that's disjunction. So for conjunction, again, and means this is true and that is true. So and is only true when they're both true, otherwise it's false. Or means this is true or that is true. And we're doing inclusive or, which means it can be that can be true or that can be true or they can both be true. And it's going to be marked as true. So or means at least one true. Later on, we're going to get to something called exclusive or, which means exclusively either this is true or that is true, but not both, and that has a different result. Matter of fact, this is true or that is true. It looks like Mr. Cunningham put the result of negation of exclusive or, but no, actually, yeah, he put the opposite of exclusive or. But that's neither here nor there. Okay, what's the time? So we have a solid 10 minutes or more. We're going to keep going. I'm going to go for another 20 minutes or so for finite math. So let's go on to the next part. Okay. So we're asked to construct the truth table for this statement form. Okay, so we have not P or Q. Okay, so now if somebody, oh, so you are finite. Okay, cool. All right. I don't think you guys can upload images. I'm just gonna do this just for the sake of time because we're almost out of time. And there will be, just being in attendance and asking questions is all I really curious to see how you guys handle. What is it? Okay, anyway. So we want to construct a truth table for this. So the example, we have not P or Q, right? Now, there's a shorthand way of doing this, but right now we're just going to fill in this truth table, right? So notice, we have two simple statements. So the total number of rows is going to be 2 squared. That means we're going to have 4 rows. And the first part of the truth table is already completed for us, for the trues and false, right? But that gives us all the combinations of trues and false that we can do with 2 simple statements. So now if we're looking at the original, which is here, right? If we were doing that, again, order of operation, first thing we want to do is simplify things inside the parentheses first. So if we focus inside the parentheses solely, we had P or Q, right? That's why we're doing P or Q first, okay? So we just said that or is true means that either P is true or Q is true, or they could both be true because we're doing inclusive or, okay? So if we look at this first row, is at least one true? Yeah, so we will put true. And if we move to the next one, is at least one true? Yes, so we will put true. Is at least one true? Yes, so we put true. Is at least one true? We put no, so that's false. False. So that would be the truth table for that part. Okay, I think Mr. Cunningham has the true, 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 false. I don't know how to get the window to show the bottom, but if you just kind of keep answering, it'll get there. Okay. I guess way behind too. It's like, but I can see it. I know you guys can't see it. I can see his chat on the side. So now the next part, as we move out of the parentheses, we want to, the next part is the not symbol here. So this. So then basically we're just saying take the opposite of that last result that we got. So now we're just going to negate. So what's the opposite of true? Is false. Opposite of true is false. Opposite of true is false. Opposite of false is true. Right? Okay. So then that would be the solution to the truth table. That false, 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 true. Okay. So what that means is that the original statement is only true when both P and Q are false. So when they're both false, then the original statement is going to be true. Otherwise, it's going to be false. Okay. So like if P was a simple statement, something that pertained to your client about being guilty, or the plaintiff, whoever, being guilty, and the other one was another one for the plaintiff being guilty. But then what this could mean is that, well, the client or the person is only guilty when those simple statements there are false. So, but if those simple statements are false, you see what I'm saying? Then you can use that in your argument for saying whether this person is guilty or Okay, so like if they told a lie about something and something else was false, then because those are false, the person is guilty. You know, if the two simple statements were false, then based on that, the person has to be guilty logically. Anyway, and then you can kind of clean up the presentation and make it more articulate. Articulation is not my forte, but you know this is just interesting stuff. So let's see what else we got. Ooh, we got another one. Okay. Okay. So we're asked to construct a truth table for this statement form. We have not P and not Q or P. So now if we have the original by itself, again, it's only two simple statements. So we still have 4 rows and it goes 2 and 2. Move up a little bit. Okay. But then the order in which we would do these, we would start with the innermost set first. So we have parentheses, but inside the parentheses, we have to decide between and not. So not actually takes precedent over and. So we would do the not first, and then we would go from there. Okay. So we're in the parentheses, but inside the parentheses, we actually start with the not Q. Okay, we're going to go for at least another 10 minutes or so. So then not Q. So the first thing it's asking us to do is do the opposite of Q, right? So we want to negate Q. So then instead of being true, so we want to negate this guy here. So what's the opposite of true? It's false. What's the opposite of false is true. Opposite of true is false, and then true. Okay. So next, now that we've done the not Q, we want to compare P and not Q. Now we just said that and means the first thing has to be true and the second thing has to be true, okay? So if we compare P, so the P column is here. We're going to compare this column. We're going to compare this column to not Q, which is this column. So these are the two columns that we're going to compare. Okay? So and this first one, are they both true? No, so that would be false. Are they both true? Yes. Are they both true? No. Are they both true? No. So again, the solution there would be, are they both true? No. Are they both true? Yes. Are they both true? No. Are they both true? No. Let's recap it one more time. So again, this says we're comparing P and not Q. So here's P and here's not Q. All right? So then and means the first thing needs to be true and the second thing needs to be true. Right? So if we look here, this first row, are they both true? No, that's why we put false. Are they both true? Yes, that's why we put true. Are they both true? No, so that's why we put false. Are they both true? No, that's why we put false. Okay. So next, now that we've satisfied everything here within the parentheses, now we want to negate that column. So we want to do the opposite of that column. Okay, so that's what the next part is. So we just do the opposite. So false becomes true, true becomes false, false becomes true, false becomes true. Okay? So we've completed all of this. All right? We've completed all of that. Now we want to compare that to P, and we want to do OR. Again, OR means at least one is true. So we're going to compare this column, or this result, to P, which is this result. We want to compare those two. We don't need that one anymore. And let's capture this. Okay. So really quickly, or and means no. We're comparing those two with or. So is at least one true? Is at least one true? Yes. 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 So it sounds like we said yes the whole way. So that means this final column is going to be true, 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 and true. Let's look at that one more time. So at the top, we're comparing that left to P with an OR. So we're comparing P and these two columns with an OR. So that means at least one has to be true, right? So if we look here, is at least one true? I mean, yeah, is at least one true? That's a yes, so that's what we put true. Is at least one true? Yes, that's what we put true. Is at least one true? Yes, that's what we put true. Is at least one true? Yes, that's what we put true. Okay? Okay. So this actually leads us into our next idea of tautology. So I need some lines because of my perfect imperfections and my beautiful, glorious, stupendous, fabulous handwriting. Paper, we need some lines. All right, and we are here. All right. Let's go back to black. In one house. Okay. So I see we only got about 3 minutes left on the clock. We're going to go for a few more minutes. I want to get over 50 minutes, but let's keep going. So what do we mean by tautology? So tautology is a statement form that has truth value. You see, this tautology is a statement form that is a statement form that has truth value true regardless of the truth values of the individual statements variable it contains. Individual statement and is it a hand? Statement variable. Is state value true regardless of the truth values of the individual statements. Let me see, of the individual statements variable, something's not right there, variable it contains. So all it's saying, notice in the last example, we did the truth table. No matter what truth value we started with, the end result was all true. So that's what we mean by tautology. Okay. So then, so that's when the final column is all true no matter what the input was. So then conversely, if we can do a tautology, then we can talk about a contradiction. Okay, so then a contradiction see the time, I'm going to get you all out of here in just a minute. So a contradiction is a statement form that has truth value false. A contradiction is a statement form that has truth value false regardless of the truth value of the individual statement variable it contains. Okay, regardless. False. Regardless of the truth value of the individual statement of the individual statement variable it contains. Statement variable it contains. Okay, so a contradiction is where after you complete the truth table, you get down to the last column, it's all false no matter what the input is. So let's see if we can give an example. All right, so here we have another example of a truth table. We want to construct a truth table for this statement form. We have not P and not Q or P. Now we're going to use this technique that's a little bit more of an efficient way. This is called like a shorthand version. So now we still have two simple statements, right? P and Q, so we still have our 4 rows. Now when we look at the original, we have the parentheses, so we would start inside the parentheses. But we would start with the and or the not Q. We would actually start with the not Q. So the not takes precedent over the and. So the first thing we would do, this would be our column 1. That's going to be the first thing we do. So we're just going to line this up under the not Q. And we're just going to negate Q. So it goes false, true, true. Okay. So then we want to compare not Q to P under the and. Okay. So we want to compare Q. Let's do this. We'll make this 1, right? So then this is 2. So this was the third column that we did. So now we want to compare column 1 and column 3 using an and. So and means they both are true. So if we look at 1 and 3, are they both true? No. 1 and 3 in this row, are they both true? Yes. And then no and no. So it should be false, true, false, false. Okay. 1, 2, 3, 4. So this is the fourth column we did. And again, to kind of reiterate that, we compare column 1 to column 3. Okay, so we said and, right? So we said P and not Q. Not Q is column 3, P is column 1. So and means they both have to be true. So we ask ourselves, are they both true? No, that's why we put false. Are they both true? Yes, that's why we put true. Then no and no. Okay. So that, then now for the not, which is column 5, we want to negate that conclusion. So we just do the opposite. So it's going to be true, false, true, true. That's column 5, right? So now we want to compare 5 to column 1 with an or. Or means at least one is true. So we have true, 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 true. I thought we were going to get a contradiction, but alas, we did not. We got another tautology. Okay, so this is the conclusion, the final column, or the conclusion of the truth table. But I think I realized that we just redid the same one we did before, so tautology actually is correct, what we should do. We are a little over, and I don't really want to go much further, so we will stop there, and okay, we'll end the session there. So, we'll pick this up next time. Let me go ahead, copy. So we'll pick up from this point next time we meet. But yeah, that was just a makeup lecture to kind of keep us honest. And so you should be able to access this video, have access to it, and pull it up and reference it as needed. And so with that, we'll end the session here. And from one beautiful mind to another, enjoy your time.